Might be, we went outside and did that activity with angles of elevation depression. It's like looking up at, how the angle in which you're looking up at something or down at something. The second application, major one, is when you talk about bearings, because bearings just refers to the directions. Like if you're looking like flat ground, the directions in which angle you're facing compared to north. And that's the sort of two major applications or ways we apply trigonometry. There's sort of two ways we talk about bearings. So we've got this one called true bearings. So we're going to look at what these actually mean. We've got true bearings, and we've got what we call compass bearings, which is probably the compass bearings is probably the ones that you guys have seen before. So we might start here. So with compass bearings, we know that so if that's north, what direction is this?
East.
East. South. West.
West.
Okay, so the way we talk about angles with compass bearings, the way we talk about angles is we might have a bearing that looks, goes in this angle like that, and if let's say it was 30 degrees, the way we would write what that bearing is, that would be north, 30 degrees towards the east. So you always start at north or south and write the bearing towards east or west. So if we had one like this, let's say, and let's say that was 20 degrees, how would that one be written as a compass bearing?
20 degrees.
Yes. South,
W.
20 degrees towards the west, isn't it? So the bearing is always south or north, and then the angle towards east or west. That's how we talk about compass bearings. Is that okay so far?
What if it's west to north, like 20 degrees?
But then you just so if it's 20. If it looks like this, that's a good question. If it looks like if that angle there, let's say we said that angle was 20 degrees, right? The way we'd say is we'd say south 70 degrees towards the east.
So you always start with north.
You always start with north or south.
Can you write that on the board?
Okay. So it's always north. So it's always north or south to east or west. That's the way it's. So it's always start with north or south, and you talk about the angle towards the east or the west. A true bearing is probably the one you're going to see a lot more in the future. A true bearing is just a bearing. It's measured. So the way this is measured is clockwise. So the angle clockwise from north. So it's actually a really easy way of thinking this is just actually think of it like a clock. So you've got this is your bearing. We know when we go to, so let's think about the main bearings here. So north is 0 degrees. So we just usually write 0, 0, 0. We write these as 3. Sometimes these are also called 3-figure bearings as well. This is just a different term for them. So you might, and so they're always written, often you see them written as like with 3 digits, even if it's not. That's just the way you often see it in the books. It's written as like, if it's 0, it's just written as 0, 0, 0. So east, what would the bearing or the true bearing of east be? What angle is that if we measure that from north? 90. So you'd say east is 90, 0, 9, 0. What about
would that be
south?
180.
South is 180 degrees. And what about west?
270.
Yeah. So that's sort of our endpoints. And then each one of that, so you can have bearings inside those that are measured. So if it said, for example, let's look at a couple of simple examples. If that was 60 degrees, what would that be how would you write that as a true bearing?
Would it be like N06?
So we don't need to write, we don't necessarily need to write.
Is it just 0, 6?
Yeah, it's just 0, 6,
degrees?
0 degrees, the angle from north. So you don't need to write, so in this one you don't need to write what angle, we always assume it's from north, and it's the angle around from north.
Can you write that underneath the thing?
We've written that here clockwise from north, it's always measured.
But like you don't have to write N.
Yeah. So this one, if that was, let's say, 40 degrees, how would we write, if that angle there was 40 degrees, how would we write that as a true bearing? What's the angle if we go around here?
Would that have to be like 130 degrees?
Good, because we've got 90 plus the 40, haven't we? So that would be the 130 degrees, and so on. So you can see they're the two ways that we measure bearings. And so
He's nodding.
part of this is being able to convert between the two of them. So the way this might link in with questions we could do with trigonometry is imagine that Lockie was walking. Let's say he's walking home, and he was walking. So this is imagine this is school. So this is where school is, and Lockie walks home in a direction of, so he walks in a direction of 60 degrees true, so that'd be 60 degrees true, and he ends up, and this is his home, right? So he's walked home, and let's say he's walked like 8 kilometres, for example. So he's walked a compass bearing or a true bearing of 60 degrees, and he's gone for 8 kilometres. And the question, we might be asked a question, for example, like how far has he gone? So remember this is north, east, south, and west. So what direction is? So we can see that home is like it's east and north of his starting point, isn't it? Can we see that? So how far, firstly, east is he? Is home from school. So if you start at school, we know that it's east, but how can we figure out actually how far east we've gone? What could we do to work out how far east we've actually
Would
travelled?
it be 40?
So if we've started here, we want to work out how far this distance here is. So we know the hypotenuse. You can see those. Can we see if we get like a different? I might do this with a different colour. Can you see we could make a triangle like this? This is a right angle triangle.
And then you'd have 30 as the angle.
And that angle there is 30.
And then would you work it out like however you...
The hypotenuse we know is 8 kilometres, and we want to try and figure out what the
The
east distance is. So it's that distance there, isn't it? Is the east distance, isn't it?
Mm-hmm.
So we could say here, we know this is going to be, if we were to label this, it would be hypotenuse and adjacent. So we'd be using the cos rule, wouldn't we? So we'd say now, cos of 30 degrees equals x over 8. And then we'd multiply both sides by what?
The 8? No,
By 8, no, you're right, multiply both sides by 8. So x equals 8 times cos 30. And then if someone can get a calculator out for me, I've actually have one here as well. That would tell us how far east we've gone. And you could do the same thing for north as well. 8 times cos 30, so that would be approximately 3.93 kilometres. So if you travel in that direction, so 30, bearing of 60 degrees, 8 kilometres, the amount east you're going to be is 6.93. And if we want to work out, so that's how far east. What about what we do to work out how far north? What would be the thing we change to work out how far north we've travelled? So how far north is home from school? What do you think we could do there?
Would you...
What would be the main difference?
The 60 degrees instead of 30 degrees?
This is the north distance, isn't it? So
yeah.
that would be that there is the opposite,
So
isn't
you'd
it?
be trying to figure that out.
Yeah, so if this is y, we'd just be trying to figure out the opposite instead, wouldn't we? Because if we look at this triangle here, the opposite length is the distance north we've travelled, isn't it? The adjacent distance is the distance east you've moved, and the opposite is the distance.
So to
north.
figure out the opposite, could you use the either O or A?
Yeah, so you could use you probably use the
Hypotenuse.
hypotenuse. So we in this case the difference is we'd use the sine rule.
But either would work.
But you have to use this one here. If you used a tan, you have to use that measurement. So if it's better to use the one that's already given to us because we're not rounding. It would work. So that's sine equals y over 8, and then that vertical distance equals 8 times sine 30 degrees, which we know sine 30 degrees is what? Hopefully we've seen this enough. A half, good. So that's just going to be 4 kilometres. So that's again the kind of thing we can do. So like with bearings, you can work. So with angles of elevation and depression, you work out how high up things are or how low things are based on the angles. You can do the same sort of thing. We're just talking about directions around a compass, like directions you can walk around. So that's really the other side of it. So they're the two main applications we use of trigonometry. That might do us, Sigrid. Thank you for that.